With the exceptional growth in science, scientists have touched different extremes of the universe, from reaching other planets and far in the universe to identifying minor levels of existence, which is one way to broaden their horizon of knowledge in both extremes. Through long periods, physicists are testing their ways to figure out the laws of quantum physics. With the rise of multiple quantum theories, one prominent theory is the existence of a parallel universe. It sounds like something straight out of a fictional movie, but it's not what you think. Some scientific theories currently suggest that there are other universes other than our own. On the other hand, the multiverse theory remains one of science's most controversial concepts. The size of our cosmos is incredible. Hundreds of billions, if not trillions of galaxies, each with its distinct properties, and billions or trillions of stars whirling through space. According to some physicists studying cosmos models, the universe's circumference could be 7 billion light years. Others believe it might go on indefinitely. How often do you think of what if there is someone exactly like you living a similar or better life on a different planet? Well, I know that most people do ponder about this quite often, but wonder if the answer to your question is a yes. In today's video, we will tell you precisely about the existence of the parallel universe and much more. In the existence of these theories, some scientists like Michio Kaku believe that we exist in a multiverse of universes, while some dismiss it by calling it fiction. Have you ever wondered if there are other life forms in the universe? Scientists do much more than ask these questions, which resulted in the birth of a parallel universe theory. Many said other universes exist, just as Stephen Hawking stated. Our galaxy has billions of stars, and there are hundreds of billions of galaxies in the universe. Our universe itself is just one of them. With multiple theories regarding a parallel universe, which one is proving true? What are the ideas that researchers claim to be true? Let's find out. Heisenberg uncertainty principle. Scientists who studied quantum meta drew a theory stating that quantum particles such as photons seem to take different forms by noticing that sometimes they behave like particles while sometimes they behave like waves. To explain this better, for example, if we are solid humans at one point, we can change into gas the next second. This phenomenon is termed Heisenberg's uncertainty principle. This was proposed by a profound physicist, Werner Heisenberg, who stated, "What we see is nature exposed to our manner of questioning, not nature itself." This theory was stepped up by another physicist called Niels Bohr. He stated that all quantum particles behave all at once. Our observation affects their behavior when we observe them, forcing them to choose one state at that given moment, making it look like all exists in different forms. We can also view Hugh Everett's many-worlds theories about quantum matter as an alternative to Bohr's theory. Hugh states that every quantum transition taking place in every star, galaxy, in a very remote corner of the universe is splitting our local world on Earth into myriad of copies of itself. Meaning, observing the quantum matter causes an actual split in the universe. As a result, the universe duplicates and splits into multiple parallel universes. However, Everett's theory is considered controversial since it conflicts with our fundamental understanding of the concept of time. Apart from being considered far-fetched, it was also considered far-fetched for many years. Still, in recent times, some modern scientists have become interested in his theory and have begun finding proof that matches by conducting multiple pieces of research theoretically stating its possibility. While if you think this is the only theory that proves its roots, it's not. String theory claims that there exists matter more minor than quantum matter. String theory is the hypothesis that reality is made up of tiny vibrating strings, smaller than atoms, electrons, or quarks, according to theoretical physics. As the strings vibrate, twist, and fold, they cause effects in many microscopic dimensions that humans interpret as everything from particle physics to large-scale phenomena like gravity, according to its hypothesis. However, we have made our way far from the Big Bang to the existence of a parallel universe by understanding different theories. We have limited access to the universe within the boundary of time. The universe as we see it began somewhere around 13.8 billion years ago in the Big Bang. when the universe was filled with hot, dense matter filled with radiation. As time passes, it becomes cool and the radioactivity decreases. Everything we know was an infinitesimal singularity around 13.7 billion years ago. Then it exploded, expanding faster than the speed of light in all directions for a fraction of a second. In a process known as cosmic inflation, the cosmos blasted outward to 10, rising to 26 times the original size in less than 10 to the power of negative 32 seconds. And that's before the natural expansion of matter known as the Big Bang, which was a result of all of this inflation. As inflation slowed, a rush of matter and radiation erupted, forming the famous Big Bang fireball and the atoms, molecules, stars, and galaxies that now occupy the vastness of space that surrounds us. After knowing all about the inflating universe, I'm sure this question pops up in your mind. How can an inflating universe create a multiverse? Before we tell you the answer, make sure to like this video and subscribe to our channel, Tech Facts, and turn on that bell notification to never miss our uploads. Let's move on. Some scholars believe that several universes are possible, if not highly likely, due to the enigmatic process of inflation and the Big Bang. According to Tufts University theoretical physicist Alexander Vilenkin, inflation did not halt everywhere simultaneously. While cosmic inflation ended 13.8 billion years ago for everything we can see on Earth, it continues in other locations. This is known as the endless inflation theory. In 2011, Vilenkin wrote for Scientific American about how a new bubble universe emerges when inflation stops in one area. Because they continue to expand eternally, those bubble worlds cannot communicate with one another. They never reach the edge of our bubble where it might collide with the next bubble universe because the edge is speeding away from us faster than the speed of light and faster than we could travel. As inflation goes on, there is a distinct possibility that the field will roll into the valley where inflation either ends or will continue, and even a certain probability that the area will move in the wrong direction, taking us further away from inflation's end, because the inflating universe continuously creates new space. All of these coincide in different regions of the inflating universe. As inflation occurs, creating more space, stretching the universe in some cases, the field rolls into the valley of inflation to an end. This results in hot Big Bangs, what we call the universe, and between those is a more inflating space where inflation doesn't end or continue, so a new place is created, hence leading to the creation of multiverses through creating space for the Big Bang. You cannot transfer anything through the universe even though every universe emerged in front of the same small space. They are not causally connected. Many theories from scientists say there is no way to test it. One of their most significant criticisms is that it is impossible to prove any theory's truth. However, there is an experiment that seems to change all of that. The cosmic ray detection test finds particles outside our universe that do not exist in our universe. How can we tell whether a parallel universe exists? If our universe clashed with the other, it might provide a means of testing. Hot patches appear on the cosmic microwave background, the Big Bang's afterglow, as the cosmos collides. If this is the case, advanced sky surveys should be able to detect them. Gravitation, which is ripples in the fabric of space-time, could also yield evidence for cosmic inflation. According to the theory, gravitational waves left behind from the Big Bang can cause soft curves in the cosmic microwave background. If detected by some telescopes, it would support the idea of another you out there in another universe, proving sci-fi writers correct.